Continue with the next topic. So we saw how a twitch works over here. Now there's another thing you should know about, which is the ability of your muscle to get stronger, to give stronger contractions based on the frequency of action potential applied to it. And we'll be talking about things like trap phenomenon and other such concepts which we could see soon. So here's the graph again: force of contraction on the y-axis and time on the x-axis in milliseconds. Just ignore the milliseconds, it doesn't matter. We're not going to put any numbers here. In red also you could see there's something called action potential over here. Now these action potentials are going to happen, and then you'll see force of contraction, meaning a muscle will contract. So this is the setup you could see in this picture over here, where you could see there's a muscle that's suspended from sort of a stand over here. And if you see the muscle at one end, there's this machine over here that measures the force of contraction. I've drawn it as a dial. It's just a very rudimentary diagram. I'm not an engineer, but I want you to understand that we have this muscle and its nerve is still attached to it, like an alpha motor neuron. Usually this is like a frog's gastrocnemius muscle, the calf muscle of a frog from its leg, which we get. So we take the alpha motor neuron and we take the muscle over here, and we have the machine over here that measures the force of contraction, and down over here we have weights that hold this muscle in place, or we can even pin it to some sort of a board and not let it move. So any contraction will cause the force to be transmitted to this machine over here, and it is going to pick up the force of contraction, the amount of force of contraction. Now look at this, we have a muscle, and if I give an action potential over here at this point of time, I am a single action potential, I will get latent period followed by contraction and relaxation. Now what happens is, this is the contraction phase and this is the relaxation phase. Just like over here, you could see over here latent period, contraction and relaxation. It's all over here. Now what if I give another action potential over here, and now naturally I'm going to get a contraction and the relaxation, and now after the muscle has relaxed completely, I'm going to just give another action potential. Now what's going to happen? I'm going to get another contraction, relaxation, but the strength developed, the force of contraction is going to be a little higher, and it will, after this also completely relaxes, I'm going to give an action potential here. This will cause a slight increase in strength of contraction again. So you could see that there is an increase in the strength of contraction by up to 50%. After this, every time the muscle relaxes, if I give an action potential, it's going to be a plateau. It won't change over here. See, I give another action potential here, and then with an electrode on this motor neuron. Okay, so then it will again plateau. Doesn't make a difference over here, but it did increase. Now this is called your staircase phenomenon or trap phenomenon, T-R-E-P-P-E, trap or staircase. So you climb up the stairs and then you reach a plateau, meaning the next floor over here. Now how does this happen? And if you read the books, they say that it's because calcium is accumulating in the muscle and it's not been completely gotten rid of. But I disagree with this completely. I fail to agree with this, because I want you to understand one thing. Certain books like Byrne and Levi would state that if you give a single action potential, you will release enough calcium from the dihydropyridine ryanodine receptor interaction to saturate all of the troponin C sites. It will all be saturated with one single action potential. That means that you add more calcium, it really doesn't matter. So what I believe the trap phenomenon or staircase phenomenon is caused by is most likely due to the heat that is developed from this muscle contraction, causing the cytoplasm of the muscle to become less viscous and more fluid, allowing the contraction to be more smooth. You understand? So whenever you contract the muscle, it generates a little heat. Imagine you get hot when you exercise. You feel hot. Your body is all pink and pumped up over there because the actin, myosin, cross-bridge cycling stuff takes a lot of energy, and there are a lot of reactions happening, and you are moving proteins, and this causes friction. And this friction is going to cause heat to develop. So there are different kinds of heat I'll talk about soon. The point what I'm saying here is the trap phenomenon, after complete relaxation. Listen, after complete relaxation, you are giving another action potential in relatively quick succession, meaning there's not too much of a break. Then what happens? There must be some more heat that's in the muscle. This should allow for more smooth reactions, more smooth power stroke, cross-bridge cycling, and reduced viscosity to take place over here. This is my belief. Then you have another thing called the concept of tetany. Tetany. T-A-N-Y, tetany. So what is tetany or tetanus? Tetanus, like the disease tetanus. T-A-N-U-S, tetanus. So what is happening over here? So you get these tetanic contractions also. If you're playing Scrabble, you can win if you have these alphabets. Anyway, so what happens here is we have a situation where I give an action potential and I get a contraction. Okay, I get the twitch. And now before this muscle completely relaxes, look, it's partially relaxed over here, I give another action potential at this point. Now what's going to happen? I'm going to get a little stronger. Okay, that's not necessary. It should be like this. Yeah, that's more physiological. A stronger generation of force. Now I give another action potential here, and now that's going to cause a higher generation of force. Now again, one more should cause a little more over here. So this is called tetanic current. You kept giving an action potential in relatively quick succession before the muscle can relax. In this case, before the muscle can relax completely. So you're getting this partial relaxation, and then again an action potential comes, and there's more development of force in the muscle than before, and then again you give an action potential before it relaxes, and now you get more force. What is happening here? So this is called tetany, and here this is called incomplete tetany. Okay, incomplete. This is incomplete. INCOM. PLETE. Okay, this is incomplete tetany. I'll just draw what is complete tetany for your benefit, and then you can understand what's going on. I'll just clear this out over here. All right, and that should make things a little easier. Now this is complete tetany. Look at this. You give an action potential over here, and you get a twitch. Now before the muscle starts to relax, you give another action potential. Now what's going to happen? It's going to again climb up. You get more strength of contraction. Now again, one more action potential, one more contraction, one more action potential, one more contraction. Now if you can keep it at this frequency, you maintain this exact frequency, what's going to happen is the contraction, the tension will be sustained continuously. It will. This is how we maintain continuous, sustained muscle contractions. This is complete tetany. Okay, this is complete tetany. Complete tetany. Now, what is happening over here? In tetany, you give an action potential, and you cause an action potential, and you get a muscle contraction. So this muscle, look at it, it's suspended over here. Now look at this, or it's nailed into place over here. Now because it's held into place over here, let's just say we held it in place, we nailed it, we hooked it into place over here. Now we are giving action potential. There will be some force developed over here. Now if I give an electrode stimulus again before the muscle can relax, what's happening here? I'm developing more force. Why is this happening, and why is this called tetany? Okay, so what really happens is, some books say more calcium accumulates in the muscle fiber. So before you get rid of the calcium, you give another action potential and more calcium gets released, and then you get more strength of contraction. This is wrong, actually. This is wrong. And there are many books which would say that it's not true, because remember, if you release one action potential, if you cause one action potential, it will release enough calcium from the L tubules to cause complete saturation of your troponin C. So what is going on really? Well, what happens is you have these tendons over here, and you have also in your sarcomeres that extend from one tendon to the other, you have these Z lines, and you have this titin. Remember the large protein called titin, and even myosin itself. So these proteins are existing, and they are attached end to end with the collagen and the elastin in your tendons also. So they're like a big spring. They're like a spring. And what happens is when you give one little action potential, you cause a quick contraction, but this spring, it's got a lot of springiness in it, so it doesn't get to transmit that force of contraction towards the tendon and cause complete development of tension at the site of insertion of the tendon, meaning at the bone. It does not stick to the it does not transmit that force to the bone completely. This is the reality of what's going on in your body. You have these bones over here, and these bones are attached at the joints over here, and the muscle is attached to one bone and to another bone, and so it contracts and it causes movement in a certain direction. Just as a silly example, I've just drawn this very bad diagram. Anatomists might murder me for this, but the concept is when you give an action potential, this springiness is in the tendon, this elasticity, it doesn't build up enough tension, so you've not transmitted the tension to the ends of the series elastic component. This is all elastic tissue in the muscle, and this is in series elastic component over here, meaning we call this the series elastic component. The titin, the myosin, and the connective tissue all constitute your series elastic component, okay, like in circuitry, parallel circuitry, series circuitry. So they're attached end to end over here. So you give another action potential, what happens is you've given enough time for this muscle to stay contracted and to transmit that force along the series elastic component. That is why there is a buildup of force, and it will build up to 4 times what a single twitch would have given you. This is complete tetany. Incomplete means you're giving a little bit of time for relaxation, and then again you contract, so that tension is not completely dispersed from the ends, so it adds up on that. So that is the real summation that's happening, and that very few people know or understand. People say that no, there's more calcium building up over here. No, that might be in the heart tissue, but again, it's more, some people say that's more in the heart. I don't want you to think of it that way. Calcium is released in adequate quantity even with one single action potential. But what happens is you are now allowing the force to transmit. You're giving time for the force to transmit. I'll give you an example. Remember, okay, if you go to the gym, you might remember there are these instruments, these elastic bands over there. Sometimes those bands are tied to the wall, and so this is the wall, and there's a band over here, and you what happens is you come along and you pull this band very quickly over here. You pull on this band very fast, like you just snap your hands back. It won't feel so hard. It won't feel so hard. So there's a elastic rubber band type thing attached to the wall, and you quickly pull it close to your body. What's going to happen? It won't feel so hard. But when you imagine you pull this slowly, okay, so the band is nice and relatively lax, you just pulled it, and now you start pulling it slowly. You can feel the tension building up. That's what's happening in your muscle. Same thing, you are allowing the tension to build up in that series elastic component, in the tendons, in the muscle fibers, allowing for the contraction to take place. So this is the reality of your tetanus. And when you are like, for example, holding a pen or holding a cup of water, maintaining a sustained contraction, holding something, so your muscles are in a state of tetany that time. There is a continuous chain of action potentials coming from your CNS to the alpha motor neuron to the muscle, causing this contraction to take place. Okay, so I hope this difficult concept has been understood by you, and now let's continue with the next thing, which is length-tension relationship of the muscle.